Now in class 11th, I will take some special numerical problems. So there are three numerical problems that I have to discuss with you because these have been asked in the NEET exams also. So from the point of view of the competition, I am taking to these three examples. So now there is the first one is the pendulum of length L. Length L is in horizontal position. Is in horizontal position as shown in figure. As shown in figure. Find the velocity and tension when it strikes the vertical wall. Find the velocity and tension in the string when it collides with vertical wall. तो आपको फिगर में ये दिया गया है, ये वर्टिकल वॉल है, दिस इज नॉट वर्टिकल वॉल, और ये एक पेंडुलम है, इसकी लेंथ ये L है. तो when it falls down like this, then you have to find that what is the velocity of this. When it moves like this one, then you have to find the velocity at this. This is no ball. So now how to find the solution? Now let us have a general formula for finding the tension and the velocity. This is now ball. This is now of length L. This is a vertical wall and it falls. So it moves in a circular path. Circular path. Let N at any instant this ball is in this position. This is in this position. And the tension is in the thread is suppose T. Now then it has the weight mg, and this is now your mg cos theta, and we have found the velocity also. Let the velocity here, this is now your v, this is now point p, and let it has formed a height h. This is now your h. So from the ground this will be how much? L minus h. This is now L minus h. So what we have at point P. At point P. Now this T minus mg cos theta equal to mb square upon r. R will be the length of this one, this length, or upon L. So this T is equal to mb square upon L plus mg cos theta. This is now equation number 1. And then for velocity, just to apply the theorem of the conservation of energy. From here, this initial velocity is equal to 0, and this falls up to this height h up to the here. Then velocity. Here we use v square equal to u square plus 2as. This is now v square equal to u is equal to 0, that it falls from here. This is the value of u. This is now plus 2 in place of g. This is now a equal to g, and s is so much vertical height, L minus h. This height is always taken from the ground, not from the upper position. So this v equal to square root of 2g into L minus h. Then this is also much is x, and this angle is theta. This angle is theta. Then we can have this cos theta base upon perpendicular. So this h equal to L cos theta. H equal to L cos theta. So this is square root of 2g L minus L cos theta. This is not so much. So this is equal to square root of 2gl into 1 minus cos theta. This is now v. This is now equation number 2. Now then we put the value of this v here in equation 1. In equation 1, put value of v. So what we get? This t equal to m upon L. This is being in square. This is now 2gl into 1 minus cos theta plus mg cos theta. Then how much you will get? This L will cancel. This is not 2mg into 1 minus cos theta plus mg cos theta. So this will be how much? 2mg. This is not so much, and minus 2mg cos theta. So this is now your minus mg cos theta. So 2mg minus mg cos theta. Minus 2mg cos theta plus mg cos theta, so this will be your minus mg cos theta. So better you take this mg to be common. This will be this mg h is velocity will be attained when this fall to the height h. So this y will break to this one. This is now your h. In h, in place of h, we will write down this L cos theta. L cos theta. So this is so much. The velocity here we will take this is not velocity. So here we take to this one as this is now your equation 2. In equation 1, put value of v. So we will have this t equal to m upon l into 2gl cos theta plus mg cos theta. The 2 l and l will cancel. 2mg cos theta, 2mg cos theta is now 3mg cos theta. This is now your 3 mg cos theta. This is now your t. This is now equation number 3. Now you can find the tension in any position from here. That you can see just at the bottom. For theta equal to 0 degree, we are taking from the vertical. This is not so much. Theta equal to at this position, the theta will be equal to 0. So what we have this v equal to square root of 2gl. This is not velocity. Tension will be how much? This t equal to this is now your 3m. So this cos 0 equal to 0. If you are having some another value of this theta, then you can find it. You can see that if theta equal to 90 degree here, then tension is equal to 0 and that the velocity is equal to 0. So for theta equal to 90 degree, v equal to 0 and this t is also equal to 0. So at the horizontal position, there is no tension in the string and no velocity. This is what we have taken it to be now here, 0. So this is the velocity when the pendulum strikes the vertical ball. Now then we have a second example. A body of mass m moves freely from point P to a frictionless curved path as shown in figure. तो फिगर में आपको क्या दिखाई दे रहा है कि ये है आपका this is the radius R, this is now height h. A body falls from here and then you have to find out what is the velocity at this point. This is now your point P and this is now point Q. This is given here. What should be the minimum height? Question is what should be the minimum height h of point P, h of point P, so that the body reaches, at top point P, at top point Q, not P, top point Q of vertical circular path, of vertical circular path of radius r. This is what the question. Then just to apply the law of conservation of energy, and we know that to reach at the point Q, the minimum velocity must be square root of rg. This we know. The minimum velocity at Q, this is your V equal to square root of R. This we know. So now apply the law of conservation of energy. Apply law of conservation of energy at, so what we have, that total energy at point P, total energy at point P equal to total energy at point Q. This is what we have. So here this velocity is falling freely. So what is it? Freely. So here the velocity is equal to 0. So this is now your half m, this is now 0 plus mgh equal to, now this is how much? Half m, and v is equal to so much, v square plus mg. H will be almost this total radius from this to this one. This is not diameter. So diameter is now your 2r. 2r. So now we put this, then simplify. mgh equal to half mv square equal to rg plus, this is your 2 mgr. So mg will cancel from all, m and g, and this mg. So this h equal to r upon 2 plus 2r. So h equal to 5 by 2r. This is the answer. So much must be the height of this point P from the ground, so that the particle could reach at the point Q, the top point of the vertical circle. This is now example number 2. This has been asked in the NEET exam so many times. And now one more example that I am telling you here is that in meter scale, it stands vertically, such that its lower end is fixed. And the upper end of the scale is allowed to fall. What will be the velocity of upper end? What will be the velocity of upper end of the scale when it strikes the ground? When it strikes the ground. This is the question. In meter scale stands vertical, such that its lower end is fixed and upper end is allowed to fall. What will be the velocity of the upper end of the scale when it strikes the ground? This is the question. So now what we have, that this is a meter scale, this is the ground, this is 1 meter. Now it falls like this. So now question is that what will be its velocity here? This we have to find. The velocity at the ground. You know that this is moving in the circular path, and we know that the velocity at the uppermost point of the vertical circle is equal to square root of rg. So here we have solution is the velocity initial velocity of upper end u equal to square root of rg. This we know. Here r is equal to 1 meter. So this is now square root of g. Then using b square equal to e square plus 2as. What we have, this b square equal to u is equal to so much. This is now g, this is now 2, a is equal to g, s is equal to 1 meter. 1 meter. This so much distance. This is now 1 meter. This is now 1 meter. Vertical height is 1 meter. equal to 3g. This is now your b square. So b equal to square root of 3. This so much. The upper end will strike with the speed of square root of 3 with the ground. So, for the better preparation of the NEET exam, NDA, etc., you have to solve the question papers of the previous years, at least 4 or 5 years. So many questions are repeated again and again. So you can find that if you study them, then some questions you can get in your coming competitive year. So this is better to solve the question papers. These questions have been asked so many times in the NEET exam. So this is why I have told you to this one. So this is all about the vertical motion, circular motion in the vertical plane. Thank you very much.